Alright class, last video we talked about what do we know about figures that are congruent, and in the definition on page 77 we know that in two figures all the parts of one figure are congruent to the corresponding parts of the other figure. So if we know that two figures are congruent, we know that all pairs of corresponding sides are congruent and all pairs of corresponding angles are congruent. But what if we want to prove whether or not two shapes are congruent? Well, if you want to prove whether or not two shapes are congruent, then you would have to prove that all parts of one figure are congruent to the corresponding parts to the other figure. So then key word being all. So if I wanted to prove that two triangles are congruent, I would need to prove that all three pairs of corresponding angles are congruent and all three pairs of corresponding parts are congruent. That's actually 6 things I have to prove. Well, that's a lot of things to show. 6 different things. We need to show that 6 different pairs of corresponding parts are congruent. Isn't there a shortcut? And actually, there is a shortcut, and in fact, there's more than one shortcut. So yes, there are 6 shortcuts. Now, I'm not going to go over each shortcut because this video would be very long if there are, but we have notes on page 79 which summarize the shortcuts in the forms of theorems and the like. Now, postulates are statements or conjectures that are made that we really don't have to prove because they're obvious. And one of the first congruent shortcuts in the book is labeled Postulate 19, which says side, side, side congruence. And that says that if I can show, instead of showing that all 3 pairs of corresponding angles and all 3 pairs of corresponding sides are congruent, if I can show that just all 3 pairs of corresponding sides are congruent, then that's sufficient to show that the triangles are congruent. So if I can show that AB is congruent to RS, and BC is congruent to ST, and CA is congruent to TR, then I don't even need to worry about the angles. I can stop right there and prove triangle congruence based off the postulate, the side, side, side postulate. Now we're going to look at another postulate that's called side angle side, which says instead of showing all 3 pairs of corresponding sides are congruent, if I can show that 2 pairs of corresponding sides and the included angle of one triangle are congruent, then the 2 triangles are congruent. So let's talk about the word included angle. Well, if I'm showing you that 2 pairs of corresponding sides are congruent, then the included angle is the angle that's in between the 2 sides that 2 pairs of sides that I've shown are congruent. So in this case, if I can show that side RS is congruent to UV, as we can see, RS has 2 dashes, UV has 2 dashes, and I can show that side RT is congruent to UW, then and if I can also show that the angle that's in between the 2 sides, or made up of the 2 sides, angle R is congruent to its corresponding angle on the other side, then I'm done as well too. I don't need to prove the other pair of corresponding angles are congruent or the other pairs of corresponding sides are congruent. I'm done. I can just say that triangle RST is congruent to triangle UVW. So let's look at an example. So in this case, we have a triangle that is special because we know that one side length is 3.7 meters or whatever units, another side length is 4.3 units, and the angle in between is 52.6 degrees. So what we're trying to do is we're trying to prove that if I were to make another triangle that has these same measurements, that one side is 3.7, the adjacent side is 4.3, and the included angle between the 2 sides are congruent, then I will also have a congruent triangle that's congruent to the pink one. So let's see. Let's try and change A so that it's 3.7. Okay, got that right. Then change B so that it's 4.3. Okay. Now, are these 2 triangles congruent? Oops, 4.3. Let's see. Does it look like they're congruent? Not exactly. And that's because we need more than just 2 pairs of corresponding sides being congruent. We also need the angle in between them to be congruent. So I'm going to change this triangle so that I still keep the side lengths of 3.7 and 4.3, but make this included angle measure 52.6 degrees. So as I make it up to 52.6, now let's see if this triangle is now congruent to the red triangle. And as you can see, it is. So in this case, this proves that side angle side is a good shortcut to use. All right, so far we have side side is a congruent shortcut, and then we have side angle side where the angle is the included angle. Now let's take a look at another shortcut, postulate 21, and it's called angle side angle. So instead of having two pairs of corresponding sides being congruent, if you can show that two pair of corresponding angles are congruent, and then one pair of corresponding sides is congruent, as long as that side is the included side between the two angles, then that's another congruent shortcut. So if I can show in this case that angle A is congruent to angle D, and that angle C is congruent to angle F, and that the angle the sides that's included between the two angles, and this is the side that's included between the two angles, those pairs of corresponding sides are congruent, then I can show that the triangle is congruent. So let's see how that works. So over here we have these two angles. This is the blue angle, angle C, and this is angle B, which is the yellow angle, and these are their measurements that are fixed, or we can change it so that it's one particular thing. And this side is the length of the included side between the two angles. So between the yellow and the blue angles is the green side. So if we fix each of their lengths and their measures, can we make two triangles that are congruent between all of them? And that's a very good question. So let's see. So remember, these angles and this side length stays the same, but we can change anything else. So I'm going to change it so that A meets up with A prime, and I'm going to change it that X meets up with X prime. And based off this, do these triangles look congruent? And if you say yes, you're absolutely correct. These two triangles are congruent. So the conclusion is, if two angles and an included side of a triangle are correspondingly equal to the same parts of another triangle, then the two triangles are congruent. So that shortcut is named ASA for angle side angle. Okay, so we can show that angle side angle is another triangle shortcut. In the interest of time, I'm not going to go in depth about the other two, but they are theorems that someone has proven. Angle side is the one for which you can show that two pairs of corresponding angles and a side that's not included between the two is congruent. Then you can show that the triangles are congruent. So actually angle side means you don't even need the included side. So as we can see here, this side here is not included. So that's angle side. And then the hypotenuse leg is basically like another version of angle, of side angle side or angle side angle, because in this case, this is only for right triangles. And in this case, we have if the hypotenuse corresponds and is congruent to another hypotenuse of a right triangle, and one of the legs is congruent to another leg of the same right triangle, then we can say that the two triangles are congruent. Okay? So in conclusion, I want to actually correct something. I said that there were 6 shortcuts. That's a typo. There's actually 5 shortcuts. And the 5 shortcuts we've talked about are side, 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 angle, 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 side, and the hypotenuse leg theorem for right triangles. And those are the only 3, those are the only shortcuts that will work. The following shortcuts are not actually shortcuts at all. They're actually fakers, and they will never work, which are angle, 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 and side, side, angle. Okay? So we're going to be doing activities proving that triangles are congruent using only these 3. That's it.